In this lecture, we'll be discussing few basic features of fuzzy membership grades, or you can say fuzzy sets. And in order to understand these basic features, we are understanding triangular fuzzy sets and trapezoidal fuzzy sets because we are understanding these features in these two types of membership grades only this time. So in today's lecture, we'll discuss membership function. Specifically, in membership function, we'll discuss triangular and trapezoidal membership function and features of this membership functions. So let us start with triangular fuzzy set. So I'm drawing this triangular fuzzy set. This is our x-axis, this is our y-axis, and on y-axis, this represents the membership grade, which in the last lecture we represented by say mu A, and this triangular fuzzy set will be represented by this triplet say A, B, C. And this triplet is say this is A and this one is B and here we have C. Okay, the membership grade in this case will be given by mu AX is equal to the function is defined as, you see, before a, that is for all the values where x is less than a. So these are the values where x is less than a. This function takes value 0. So we can write here it is equal to 0 if, or you can write for x less than equal to a. Now let us move forward. Now see this one. This area, you can see this area. Let us mark it with red. If we see this area, it is governed by x minus a upon say b minus a. Right here, x minus a, b minus a, and this value is between a and b. If you remember, this is here. So we have x greater than equal to a, less than equal to b. See, here also equality is there, here also equality is there. If we put x is equal to here as a, we'll get 0. So this one is justified. So let us move on to this line. So we are here on this line. If you see this line where I'm putting the dots, so this line will be governed by c minus x upon c minus b, where c is this point. If you put this x as c, we'll get this value c as 0. Now we'll write this as c minus x upon c minus b if b is less than equal to x is less than equal to c. Now what are the values beyond c? Beyond c. So if we go beyond c, the values are 0. So we'll write 0 if x is greater than equal to c. Now we can see this is the membership grade. This is a function using which we represented the fuzzy set, and this one is the example of a triangular fuzzy set. So we have triangular fuzzy set. Let us represent in a similar way the trapezoidal fuzzy set. So this is our x-axis, this is our y-axis. Again, in a similar way, this represents the membership value or membership grade, and we usually represented it by mu ax, or you can write mu a only. We represent the trapezoidal fuzzy set. You can see the shape as a trapezoid. So as A, B, C, and D, 4 points. Let this be A. This one as B. Let this be C. And the last one is D. Okay. Now there's a time to write the membership value or the formula, you can say. Okay. So let us start writing. So before A, if we see this point, the membership function takes value 0. So this is the value. So it takes value 0 if x is less than equal to A. Let us see the value between A and B. That is, we are saying this value. So if we go through this line, it will be x minus A upon B minus A. You can put the value of x here as A and check what value are you getting. So it is x minus A upon B minus A if x lies between A and B. Further, if we go here, the straight line parallel to x-axis, so it takes value. If we assign this value, say let this is 1, let this is 1, it is taking its maximum value. So if it takes maximum value, we'll write it as 1, and 1 value it takes between B and C. So it takes value 1 if it lies between B and C. Further, let's move on. Let's see this line. So here it is d minus x upon d minus c. So our function takes value this from c till d. So we'll write here d minus x upon d minus c if x lies between d and c. Now let us check the values beyond d. So values beyond d is 0. So we'll write 0 if x is greater than equal to 2. So this is a triangular fuzzy set. So we wrote the membership values also and we represented it graphically also. So this is a triangular fuzzy set. Now it's time to discuss the features of these two fuzzy sets, both triangular and the trapezoidal. So as we have to discuss the features of membership function, so we are discussing features. First feature is support. So first feature which we are discussing is what is the support of a fuzzy set. So support of a fuzzy set is represented by this support. Say if the fuzzy set is A, we write as support of A. So support of a fuzzy set is always a crisp set, students. So it takes value on the x-axis. So we have all those elements of x-axis whose membership grade is greater than 0. So let us see in triangular fuzzy set what does this mean. Students, we are assuming here that the maximum value which this membership set, this fuzzy set takes is 1. Here also the maximum value taken is 1. Okay. So what is support? All those points where the function takes membership value greater than 0. So you can see the membership grade from A till C, where A and C are not included, is support of A. So this is called the support of A. Similarly, if we see in triangular trapezoidal fuzzy set, support is this. Support of A is this. So this is our support, where the function takes value always greater than 0. Okay, so next feature which we'll be discussing is, so core in trapezoidal fuzzy set is this. So this is score of this trapezoidal fuzzy set. If you see in triangular fuzzy set, what is score? Where the function takes value 1, it is only 1 point here. And in trapezoidal, it is from B till C. So this is the core of a fuzzy set. So here, from here, we can easily say that core of any fuzzy set is a subset of support. Because if it takes value 1, it is always greater than 0. And when will the core equal to support? When will this happen? When will this happen, students? This will happen only if A is a crisp set. If A is a crisp set, then only this will happen. Otherwise, this will always be subset of supporting. Now let us move to next one, boundary of A. So what is boundary of a fuzzy set? So we say boundary of a fuzzy set A is all those points where the membership grade is less than 1, because if it is 1, it will go to core, and greater than 0. Okay, so let us see what is the boundary in this case. So we have seen, students, so from here till here it is support, till D it is support, from B to C it is core. And what is boundary? The region left here. So this is boundary here. Here the membership grade is less than 1 and greater than 0. Next thing is height. What is the height of a fuzzy set? So what is height of a fuzzy set? So it is maximum membership grade, largest membership value of its members. So we can always write as largest membership value. So while drawing triangular and trapezoidal fuzzy set, we assume that it takes value 1 here also and here also. So in this case, the height is always 1. So if we want to represent the height, so this will be the height of fuzzy set. In this case, the height is 1. In some other cases, the height might be less than 1. Okay. So next feature which is there is crossover point. So crossover point. So what is a crossover point of, say, any fuzzy set A? Crossover point of any fuzzy set A is collection of all those points of capital X where the membership grade or membership value is 0.5. So this is crossover point. So let us see this with an example. So let us consider an example. So let us take the universal set X. Let us take all those values as, say, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85. And let us move to 90. Let this be ages of uh, human being in X. Let this be the universal set of age domain. Now let us define a fuzzy set So we are defining the fuzzy set as young. So this is a fuzzy set of young, and let this fuzzy set A be defined as, students, in the last lecture we showed you how to represent a fuzzy set. There are two ways to represent a fuzzy set. So these two ways are, we discussed in the last lecture. So these are the two ways. One is this one. We'll write the element and the membership grade, B and its membership grade, so on. And another way of writing is this. Okay. So this we discussed in the last lecture. We are following the very first way of representing. So let us write it. So let it 5, it takes value 0. At 10, it takes value, say, 0. At 15, it takes value 0.1. At 20, it takes value 0.2. At 25, it takes value 0.3 or maybe 0.5, because at 25, we are quite young. So maybe at 0.6. At 30, let it be 1.0. At 35, let us reduce it and let it be, say, 0.9. At 40, let it be 0.8. 45, let it be 0.7. So this is our fuzzy set. We will find the support. So this is our fuzzy set. We'll find the support of this fuzzy set A. So it is nothing but all those points where the function takes value greater than 0. So let us find it out where it takes value greater than 0. So it takes value greater than 0 at 15, 20, and till 65. So it starts taking value 15, 20, 25, 30, 35, so on till 65. Then we'll find the core A. So it is nothing but all those points where the function, remember, that is the membership grade, is equal to 1. So this is, let us see where it takes value 1.0. So it takes value 1.0 at only at 30. Yes. So it is nothing but 30. Next is, let us find the height of the fuzzy set. So height is the maximum value. So maximum value which this fuzzy set takes is 1 at 30. So height of this fuzzy set is nothing but 1. So let us move to next one, and that is boundary of the fuzzy set, right? Boundary of this fuzzy set A is all those points where this fuzzy set mu ax takes value less than 1 and greater than 0. So we have a lot of values here, greater than 0 and less than 1. We have 15, we have 20, 25. So it is 15, 20, 25, and less than 1. So we won't include 30. And then 35 is there, 40 is there, 45 is there, 50 is there. And moving further on, 55 is there, 60 is there, 65, 0.1 value, 65 is there. And that's it. We won't be taking 70 because it is 0. We won't be taking 75, again 0, 80, 0, 85, 0, and 90, 0. So this is how we can find core, boundary, support, and height of a fuzzy set. So students, if you still have any problem, you may write in the comment, and thanks.